You compare science to magic. Explain that to me.
Well, that's slightly tongue-in-cheek, really. What I mean is that there's a central magic to the way that science is done, which people don't understand. Okay, so it's possible to write down a mathematical formula on a piece of paper, on a blackboard, on a whiteboard, and that predicts the existence of things which no one had ever suspected. You know, it could be black holes, it could be the Higgs particle, whatever. And when people go and look, they actually find these things exist in the real world. So the magic is that the universe, the real universe, has a mathematical twin that mimics it in every possible way, and we don't know why. So famously, the scientists themselves cannot quite believe that this works. So famously, Einstein did not believe two predictions of his own theory of gravity, which were black holes and the Big Bang. So it's very hard to believe that a piece of hieroglyphics that you write on a piece of paper actually reflects the real universe. So that's the magic.
Why do you think mathematics is so good at explaining science?
Well, that is the key question. And unfortunately, it's impossible to answer that question. Eugene Wigner was an Austrian physicist, and he famously talked about the unreasonable effectiveness of mathematics in the natural sciences. You know, why is it that the real universe has this mathematical twin that you can put on a piece of paper? And actually no one has an explanation for it. So it's a deep mystery. Paul Dirac, who was a great British physicist, I write about him in my book. In fact, he's the only scientist with his formula on a flagstone in Westminster Abbey in London. He always talked about God being a mathematician. He was not a religious person, but he used that as a metaphor that the universe is mathematical.
Who's your favorite magician of all the ones that you wrote about?
I suppose it's Paul Dirac, really, because Paul Dirac, if I tell you that most physicists think like you and me, okay, so obviously they know a bit more mathematics, but they're basically trying to think of models of the real world, you know, to try and understand it. So famously, James Clerk Maxwell, who was a Scot and was probably the greatest physicist between the age of Newton and Einstein, he imagined magnetism. He tried to explain how a magnet could exert a force over empty space, you know, how it can pull a paperclip. And he imagined that all of space was filled with these tiny little invisible cogs. So he imagined that the magnet turned a little cog, which turned another cog, and eventually touched the paperclip. Now, so he thought just like us. But Dirac was completely different. He liked pretty mathematics. So he liked playing with mathematical formulae on a piece of paper. So he didn't have any physical models like we would have. And in 1927, November 1927, he was trying to the big problem was we had quantum theory, which is our theory of the microscopic world of atoms and their constituents, and we had relativity, which had been thought up by Einstein. Relativity describes things moving near the speed of light. It turns out in some atoms, some small things, the electrons are moving near the speed of light. So you need to combine these two theories. So in the late 1920s, this was the problem. How did you combine quantum theory and relativity? Now, Dirac, sitting at his desk at St. John's College in Cambridge, literally wrote down a formula in November 1927, which he thought was pretty, and actually described an electron. It was probably the formula with the most implications of any formula ever devised, because it predicted the existence of antimatter. Okay, there's an entire universe with antiparticles. So we have an electron, there's a positive electron, we have a proton, there's an antiproton. So that was not suspected. So he actually just guessed this equation. So that really emphasizes this magic, that you don't even have to have a physical picture, a mental picture that you and me would have, but you could just actually get a piece of mathematics and the universe reflects that mathematics. So I think Dirac was probably the greatest magician. And also he was a completely weird character. He was the Mr. Spock of physics. He was very literal. He used to walk around on Sundays around the villages around Cambridge and climb trees in his suit and tie. And if a student in his lecture put their hand up and they said, "Professor Dirac, I don't understand," he would say, "That's a comment, not a question." and just continue with his lecture. And he had this friend called Peter Kapitsa, who was a Russian, who wanted him to read Russian literature, and eventually he got Dirac to read Crime and Punishment. And when Dirac came into the office on the Monday, Kapitsa said, well, what did you think? And all Dirac said was, on page 257, the author has the sun rising twice in one day. And that was his only comment. So he was an extraordinary character. Today, we would probably class him as on the autistic spectrum.
After people have read this book, what is it that you want them to take away from it?
Well, my book is, although we started talking about this central magic of science, which of course is a mystery, my book is really about the people, the magicians who've demonstrated this. So it's really a book about people and the stories of discovery and what it's like to actually find something and know something that nobody else in the world has ever known. So it's actually really, just great stories, many of which I've never seen written up. So, for instance, the people who tried to detect the neutrino, which is, if you hold up my thumb, 100 billion neutrinos are flowing through my thumb now every second. 8.5 minutes ago, they were in the center of the sun. Neutrinos are particles which are produced by the sunlight generating reactions in the sun. Now, the people who tried to detect it, they were going to put their experiment 50 meters from the explosion point of an atomic bomb. So how amazing is that? They were going to drop their experiment in a shaft, which they dug, a vertical shaft they dug in Nevada. They were going to drop it 150 feet so that when the bomb went off, it would not be the experiment would not be in touch with the ground, so it wouldn't get the shock waves. And then they were going to have like mattresses and feathers at the bottom of the shaft to cushion its fall. And then 2 days later, some poor person was going to have to go through the radiation-scarred landscape and actually retrieve the experiment. So I tell all these stories of all these weird and wonderful experimenters and people who predicted things. So it's about people, really.